We now discuss the solution of a problem from the section Mathematical Reasoning. This question has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the second shift. The given question is the maximum number of compound propositions out of these 9 compound propositions. So these are 3, 6, 9. The maximum number of compound propositions out of these 9 that can be made simultaneously true by an assignment of truth values to P, Q, R and S is equal to. And we have to find out the maximum number of these compound propositions out of these 9 that can be made simultaneously true by an assignment of the values of P, Q, R and S. So by a single assignment of the truth values of the quadruple P, Q, R and S, these 9, how many of these 9 are simultaneously true? That's the question. Let's now discuss the solution of the problem in detail. We are given 9 compound propositions. These are the 9 compound propositions, and once again I will write down here. So these are the 9 compound propositions. Make an observation. In this, there are 3 compound propositions which contain S. This one, first one, third one, fourth one. And the remaining 6 contain negation of S. Negation of S, negation of S, negation of S, negation of S, negation of S and negation of S. 6 of them contain negation of S and 3 of them contain S. So this is the red ones are those containing S. The black ones are those containing negation of S. There are 6 compound propositions containing negation of S. These are the first 3, the next 3, 6 of them. Agreed. Now we remember this one. X is a statement. X or truth is identically equal to true for all truth values of X. Whether X is false or true, X or true is always true, and this is true for all truth values of X. Now, if S is false, negation of S is true. So in all these things, negation of S, that is true. This is T. And the remaining one is X. The remaining one is X. And we have seen X or true is identically equal to true for all truth values of X. That means when S is false and each of these 6 propositions will be true for all values of P, Q, R. For example, if you take P or R or negation of S is true. How? Is true for all truth values of P and R. How? Negation of S is true. So this is X or true is true for all values of X. So this is true for all truth values of P and R. Okay? So likewise, each one of them is true for all truth values of PQR, because QR are also there. So that is the, that means you take S to be false and PQR or anything true or false, then all these 6 will give you the truth value true. Agreed. Now what about the remaining 3? We are going to discuss about those 3 in the next slide. So now consider the remaining 3 compound propositions. These are the 3 remaining compound propositions containing S. Right. Let S be false. Let S be false. So because in the earlier also we have taken S is false and negation of S is true. So this is the same thing we are continuing. Let S be false. So now recall. True or false is identically equal to true. So S is false. S is false. And these 3 compound propositions will give you the truth value T if P or R is true, P or negation of Q is true, negation of P or negation of R is true. Then the above 3 are true if P or R, P or negation of Q and negation of P or negation of R are true. And when are they true? Suppose you take P to be false, and Q to be false, R to be false, let us say. Then P is false, R is false, P or R is false. But we want true. Therefore, let us say P is false, R is true, let us say. Then P or R is true. Now P is false, P or negation of Q must be true, then negation of Q must be true, that means Q must be false. So if P is false, Q is false, then P or negation of Q is true, negation of P is true, or F is true. That means these 3 are true when. So these 3 are true when P, Q, R respectively takes P is false, Q is F, R is T. So P, Q, R respectively takes FFT, takes the truth values FFT, and of course S is false. Then all these 3 compound statements are true. Thus, the above 3 compound propositions are true when P, Q, R and S respectively assign the truth values F, F, T, that is P, Q, R. For S, it is F. So F, F, T, F. So P, Q, R, S respectively assign the truth value F, F, T, F. These 3 compound statements are true. And we have already seen the above 6 compound propositions are true when S is false and for any values of P, Q, R. Therefore, if I take P, Q, R to be F, F, T, even then, and S is false, then these 6 compound propositions will also be true. So, further, the above 6 compound propositions are true when P, Q, R, S respectively assign the truth values F, F, T, F. Because S is F. So thus, this shows that all the given 9 compound propositions are simultaneously true when P, Q, R, S are respectively assigned the truth values F, F, T, F. So we wanted to find out the maximum number of these compound propositions out of this 9, which are true, simultaneously true for an assigned truth values of P, Q, R, S. and the answer is 9. The number of such compound propositions out of those 9 is all the 9. So the answer to this question is 9. That is the detailed discussion of the solution of the problem from the section mathematical reasoning, and it is definitely an interesting question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.